action about development support system. It's a very important topic for a number of reasons, not just because the system development logic control helps us to improve the quality of applications that we develop, applications related with security and non-related security, and also from the point of view of legislation, due to the fact that in recent documents, legal documents, especially state documents and personal data in documents on state informational systems, they have included requirements for certain levels of security, and they have to apply mechanisms of secure development to increase the quality and security for the software being developed. Also would like to tell you about the experience of how this can be done. Our section is done in a following way. It will be started by Anton Karpov, the Yandex security department manager, with general methodological outlook at what SDLC looks like and how the process of the analysis of the quality and development of the secure development of the software. Then I will tell you about how this was done in our company, Cisco. Then General Director of the Procast Security will tell you about search of links in the source codes of different applications, and Denis Baranov from the company Positive will tell you about different mechanisms of source code analysis for vulnerabilities and other security function violations. If we'll have enough time, it's not a fact that we'll have enough time because the section is very short. We'll try to answer your questions, and right now, not to hold any more time, I will give the floor to Anton Karpov. Thank you. Good evening. Dear colleagues, friends, thank you, Alexei, for an opportunity to begin this roundtable. Today we're speaking about SDLC. This is a very important topic, especially in Russian security market. It's a new topic. Just 2 years ago, nobody was even speaking about it. Nobody was even thinking about it. The topic which even doesn't have a strict definition. Somebody called SDLC, somebody called SDL, but nevertheless in the world, globally, this is not a new topic. And speaking about me, when I faced it several years ago when I've been working in foreign company. But today we speak about this in Russia, and I would like to share our opinions about practical aspects of realization of SDLC or SDL, whoever likes what. And I would like to share with you some experience in Yandex, at Yandex. Well, first of all, let's define what are we speaking about. SDLC is a big topic which includes a lot of different aspects, and everybody understands it on the level of his own knowledge of this topic of safe development. We think that from the practical point of view, there are three main pillars on which everything is being built. First of all, it's testing, product testing, software testing by black box pin test method or by white box analysis of the source code. The second important one, is the training of developers, so that developers would write safe code from the very beginning. And number three, processes around all of this. And the final one is the most important one, because as a rule the first two things are clear and understandable, because some utilities been purchased, some courses, but the process itself, how to do that properly. Speaking about the process, you know, we would like to remember three main steps, three main concepts in the evolution of any safe processes and safe code development processes in any company. At the initial stage of understanding, it's the absence of processes at all in many companies. Maybe some local actions, you know, firefighting. For example, you have found some vulnerability, you immediately go and fix it, then you prepare a new product for the release, and then you think, well, you need to do the audit of it. But generally speaking, at the first stage of, due to the absence of the processes, safety in your company, in your development, is on the level depending from how well equipped is your technical specialist, how well they understand these security questions, how well the developers understand this topic, how well the administrators understand this process. No processes at all. On the second stage, you suddenly understand something is to be done with it. And the first thing that you come to, let's buy these tools, let's buy tools. Well, this is where most of the Western companies are located. Unfortunately, Russians are still in the previous slide with the cat, and the process is built around the tools. And only then, only maybe on the third iteration and the third stage of this evolution, you have a clear perception of your own processes, and then you select tools for applying them to these processes. So what are the main motivations in the internet companies to implement the safe development logic? Because most of the IT companies, typical companies, are vendors, and two main drivers for the vendor is to do SDL, implement SDL, or the requirement of the compliance PDSS, or the requirements of the customers. And we live during days when security is a competitive advantage, and if you make a product, your competitive product, and your competitor says that he has better, safer product and he has better SDL, so this is a reason for your clients to think about maybe whether they have to go to the competitors so they don't spend additional money and efforts for the implementation of safety into your product. That's how most of the typical IT companies, they look like that. But why internet companies need that? And they look like this. Very often, the answer is very simple one. It's a common sense, because as you will be able to see afterwards, SDL is a logical development of testing as such. If you will look at a revolution here, in the beginning, what do we have? First, it's a testing by the black box method. And this is what everybody call a pin test. And during this event, we have representatives of consulting companies, representatives of client companies. So be confident, if you have nothing, consultants will gladly sell you a pin test. It's very clear, it's very understandable, it can easily be sold to you. Then you understand that, well, you have to do the testing on some regular basis. Test it regularly, test before new releases production, and then you make the testing by the black box as a part of your functional testing. This is an ideal case, and some time ago, we also thought that this is the right way to do it. Then suddenly you understand that if you will look into the code and if you look at the source code of your products, then strategically it's a more beneficial way. A simple example, for example, you have a product and you have some unsafe code in it, which has SQL injection in it. And the user input is absent, so the tester will never be able to find it in the Windows, because he will not say that the code is bad and it's not possible to exploit the vulnerability. But you all understand that developers in all companies, they love to copy pieces of code from product to product, and the next product will inherit this vulnerability as an exploitable one. And so it's better to fix it from the very beginning and initially write a safe code and save it, and whether you do it a black box coding. So SDLC, compared to other popular terms like APT, for example, this is not a buzzword, but it's a logical continuation of basic processes of testing. Speaking about the analysis of the source code as an important component everybody comes to, and today our section is about, well, we call it SDLC, but we also will speak about the analysis of the source code, because this is a good next step of development. Speaking about the source code analysis, we want to specify two main topics. First of all, safety is defined by quality. You have to understand then, if the code is good quality code, proper code, it won't have any problems, or it will have little problems. And otherwise, if the quality of the code is bad, then it will have vulnerabilities. So from this, we come to the main rule. If you have decided to introduce certain utilities, some tools to analyze the source code, You have to understand this is a product not for safety people but for developers. They have to fall in love with it, and it's not important that they will find some losses of memory or some unused pieces of code and not buffer overflow or the format of the line that you would like to see more safe. So security is decided by quality, and the worst example how this should not be done: when the safety guy launches scanner finds millions of vulnerabilities, he gives a report to the developer and says, fix it. To the developer, it will take several months. He doesn't understand why he needs it, and the developer says he won't do that, or they hire another company, and this other company does it for big money. Another important topic that we have to understand: you have to build a proper mechanism of work with the analysis utility for the source code, because in any case, when you launch and you scan your code, initially you will see a lot of vulnerabilities. What can you do with them? It will take months and millions of the lines of code, months of analysis. You shouldn't do that. The tactic which works, it's a very simple one. Let's decide that the whole code that you have today, which is available today, select only those high-level defects, high-level criticality defects, which you have discovered. Maybe you will have less of them. Maybe there will be less of false positives, and you have to solve problems with them. For medium and for low influencers, you have to forget about. Step number 2: all the new code that will be written by your company from the moment of implementation of this analysis system, code analysis systems. For example, first 2 years you have to pay attention to high and medium ones, or only to high ones, depending from the criticity of the code. Then in 3-4 years, then you will have to start paying attention to vulnerabilities of the lower level of criticity. Then it will help you to organically develop the process of work with the source code without any problems for your developers, without any headaches for your developers. And the next topic is not really a typical one. It's typical for many companies, but nevertheless, many internet companies, they also look at the processes of secure code development, and they have these approaches. And today we've been speaking about it during previous sections, and I'm talking about outsourcing. About incentivization programs for vulnerability, because honestly speaking, this is nothing else but crowdsourcing to test your products. This is also an important part of a process, and you know that Yandex has an initiative which is called Hunt for Errors, and today I would like to share with you certain numbers. Possibly they will be interesting to you. 8 months since September of the last year, we have introduced this program. More than 500 vulnerabilities have been discovered, and we've been informed about it. And until right now, we already have paid more than 2 million rubles to all stakeholders. And I would like to tell big thanks to those people who participate in this program. Your results, your reports are very important component for the cycle of the safe development. And on this slide, you can see details if it is interesting to you. Well, this is a business section, but on the other side, this is a conference, technical conference. We have a lot of technical people here. And on this slide, you see the distribution by different types of vulnerabilities that were discovered in the course of the 8 months. So I would like to say thank you very much to all the investigators, to all the researchers. And notwithstanding the fact that right now this is mostly the work done by internet companies, but we think that Big Bounce is yet another component of the cycle of safe development. I think that I was able to speak within the time given to me. If you have any questions, maybe I'll ask them. You will ask them right now, or maybe after my colleagues. Well, thank you very much. Thank you. Can I ask you a question? Yeah, one question while I'm launching the next. I didn't hear the question. Under modeling the threats, you understand those threats against products, or what? What do you mean? Code analysis. I don't hear the question, unfortunately. Questions which are not asked into the microphone cannot be translated. These are different things. Architectural analysis, paying attention. Yes, it has to be done, definitely. Possibly, I didn't speak about some obvious things. Architectural analysis has to be done. What about threat modeling? I would call it in the same classical methodology of risk analysis. Just different applications, just different words. To different applications, different attention should be paid. Yes, of course. And nobody says that by launching bug bounty you can put a vulnerability for the internal safety comment. Well, they focus on more important priorities from the risk point of view. If you meant that by saying what you just said. I don't hear the question. So, I did mention that topic number 3, processes. This is the most difficult and this is the biggest part of our work, but you know, these things, it's very untangible. They are not tangible because they have to be limited by your company. And some general recommendations, like according to our practices, general recommendation is general recommendation. That's it. So this or that way we approach some specifics by testing. Of course, the testing cannot be anything in a year, and it's the part of a certain process, some of a certain plan. That's true. Thank you. Dear colleagues, I will continue. I'm not going to be so methodological like Anton, how we do it, because it would take a lot of time. So I will speak about the most interesting things that we've done in our company from the point of view of SDLC, LDLC, SDLC. And you have to understand that Cisco's company, first of all, it's a hardware company, even though, well, the software works on the hardware. So for us, not only the analysis is important, the quality for the software, but also things related to the hardware, to risks related with delivery chains, in builds on the hardware level, equipment in cheap buildings. So when we speak about it inside of our company about SDLC, it consists of 2 parts. Code analysis and everything which is related with processes around it, starting with requirement collection to the development and all the way to the output testing and collecting the feedback from the side of the client. And the second part that I'm not going to speak about, it's a very specific topic related with the built-ins analysis in the system part, in the hardware equipment, which is base or which makes the basis for our equipment, like mobile phones or plasma TVs for telepresence, networking equipment or means of protection. And I'm not going to speak about that. And the topic is very specific, and we don't have enough time to speak about it. We, as many other companies, we do have a concept like secure development life cycle, which consists of a number of parts, number of components, from collection of requirements to the safety for different products, because SDLC for us is not only secure development, but also development of the secure functions which can be in the function of a product. It's also a small part which is present. Then also things related with testing, related with modeling threats, with risk analysis, graphs of attacks, etc. And statistical dynamic analysis, output testing, feedback. So the whole complex of measures which have both organizational and technical character, and it's applied by different tools are applied, tools that we develop and tools developed by third parties and sold on the market. So if you look at the accounting of SDL on all the stages, then in the framework of this process, In the beginning, we collect the security requirements which depend on the needs of the client, on the needs of certification labs too, and test labs in Russian terminology, and from the needs related to bulletins of vulnerabilities in third-party components on basis of which Cisco solutions are being based, whether these are controlled servers that can work on Linux or on Windows, and etc. And of course, our own research related with security, in result of which new requirements are being developed for the security, which secure development also being realized at all stages of development, starting with planning of the product and all the way to the output testing. We also use practically all the best practices related with this particular topic, like widely adopted and very non-traditional ones. But by non-traditional, we mean those which are not applied very often in the companies, including IT sphere companies. And one of the examples, very popular example, and practically any IT vendor can boast that they do special conferences related with information security of their products. For example, we have the similar conference, it's called SecCon, and it's dedicated to internal. So people from outside cannot get to this conference. In the course of few days, different divisions which are involved in development, they share their own experience about how they achieve these objectives, and they invite various experts, external experts from other companies, our partners, Microsoft, EMC, developers, and companies which are involved in analysis of the software code, and those who sell products, static, dynamic analyzers, pin test services, and they share experience how they've been doing this work in relation to Cisco products. Another interesting topic, trainings and awareness improvement programs, because products are products, but engineers, how the engineers and developers and testing engineers, they should know what they do and what is the main reason why they do and how to do it properly. So the best practices should be informed to them. So we have implemented a program which is called Security Ninja, Cisco Security Ninja. So this is some kind of a system of motivation and stimulating of studying the SDL questions for our developers, for our consultants, and other specialists involved in security questions. Well, this is a standard grading system, belts system, on the increasing. Well, it helps them to show their own potential inside of the company and some acceptance among the clients in a given particular area. And of course, this in a certain way place for the internal social packages, because the higher is the grade, better is the belt, the more the person receives as a salary in the company, as an incentive. Another topic related with the fact that we as a company which proposes products to clients, we have internal analysis and research for the protection of our products. There's also external analysis from the side of not of the client, but when different problems arrive from the clients. Internal analysis, the internal group of fast reaction, it's called Product Security Incident Response Team, and external one, I don't know how it's been, Technical Something Center, which helps to the clients which have the service contracts to find out why this problem happened while exploiting the product. And as we can see from the given statistics, from inside we have much more, and this is the result of implementation of different procedures and tools and programs of stimulation to the employees from the point of view of improving the quality of and protecting of the software code that has been developed by us. And we have a concept as a threat library which speeds the development time, because this threat library has traditional things which should not be allowed, with examples on those languages which are used inside for the development of various products. If this is a hardware, not hardware, but a networking equipment, this can be CIS and its analogies. If this is our cloud technologies, this can be some Python, Perl, etc. And depending what is the language that is being used for the development of the product, different constructions are applied, which should not be introduced during the development. Of course, all these constructions are prioritized and they are connected to a widely accepted classification. And this slide shows you that common classification, for example, SANS classifications or a WASP classification of vulnerabilities is a little bit different in our side. Well, it is obvious that there is an average temperature in the hospital and there are certain specific things related with specific developer, and they can see different vulnerabilities and which are even higher priority than commonly accepted ones like SANS 25 or Avast Top 10. So as you can see it with the description of the construction, what can be the consequences and which measures should be applied for neutralization of these threats. Of course, we apply mechanisms related with threat modeling, usage of different graphs of attacks, and you can see this scheme in a simplified option for telepresence technologies, and similar examples are available in other products that we develop, also in all their variety. For each threat, we evaluate the risk, like Anton have said. You shouldn't eat the elephant as a whole. You should eat him piece by piece and remove highly critical vulnerabilities, then medium level vulnerabilities and low level vulnerabilities when you have time, resources, and you have a possibility to remove them. So with the help of standard methodology, CVSS, we can evaluate the risk of every threat, and then we can prioritize the work of a developer in order to remove those problems that were discovered and which can be discovered in our problems. This similar scheme exists for our cloud technologies because we propose cloud services. So we have our own baseline, this set of problems in application to our service, products and technologies from the point of view of information security with the consideration of description of why is it bad and how can this be neutralized by an example of certain constructions which describe how it should not be done. Of course, we have certain recommendations on protected programming, secure programming. In addition to a description of the model and library of threats, we also have the library of principles and good practices, best practices on secure programming. For example, how you shouldn't do the buffer overflow, how you get around SQL injection, how you can go around the cross-site scripting, and depending on those priorities and threats that we're fighting against, there are sets of recommendations depending on those which language of programming is being used for writing various products or parts of certain products. And the same thing is related to the cloud-based services. We have traditional things for our traditional segment, networking equipment, IP phones, video conferencing, security systems, and we have separate recommendations related to the cloud products and services, which to us are really critical ones and priority direction of business development. Also, there are recommendations for testing of the software, which include things related with some manual analysis, manual code analysis for small, narrow applications, like applications of different systems of statistical dynamic analysis, black boxing, etc. So various different schemes are applied depending on the criticality of the product or various subsystem that is being checked. So in some cases it's a simple pin test, in some other cases it's a more in-depth analysis all the way to the manual analysis of the source code and search for some fact that some automated instrumental tools that we will speak about later wouldn't discover. And of course there are certain software products which can solve this objective. I'm not going to speak about all of them because I'm not going to even call the names of the products, but we'll show you several examples that we really use a wide set of products, internally developed products and products which were purchased by us in companies which are specializing in development of this particular segment of the market. So honestly speaking, the wide spectrum of various technologies which allow us to evaluate that the software code was developed according to the secure practices and cooperation between the components. Networking cooperation does not allow breaches of various security requirements defined in our baselines on which all the secure development is being built. And of course, because of the fact I mentioned that we are the hardware company and we have a big number of hardware components, it's not enough to check the software. And one of the examples when we speak about very critical topic as electrical energy, for which we have specific equipment, special smart routers or smart grid switches, which transfer critical traffic between different elements of energy high intellectual systems. And of course, in addition to testing the software, we also have to test these objects from the point of view of the hardware. For this, we also have developed special tool set which allows us to follow basic, in a number of cases, and extended functions reaction to various influences on the equipment on the hardware level in order to figure out possible faults, to evaluate the work for a brick and other things which have to be on the side of the testing of this product that will be sold to the client. And of course, the final point that we have demonstrated to the top management, because SDLC, this is something which is understandable to the developer, to the safety people, and they they can do different mechanisms and tools, best practices. They go through trainings and awareness improvement. They receive black belts, white, green, purple, whatever. But why business needs that? And Anton was speaking about that. But we have another topic. How can we demonstrate to the business that things that business think about can be fulfilled on a level, sufficient level, understandable to the business? Because business does not understand cross-site scripting and SQL injection and other things. They operate with other things. And we have a system of matrices, some KPIs, which allows us to assess various products. Our cloud service, for example, on how are they complied to the information security. So top management shouldn't think about what should be done, what is not done. So he says that this system builds these indicators automatically, and if there's a need, if they see that something is on the red level, like in 3 indicators, the level of security is before the required level, they can invite the head of the certain department of the development department and stimulate him to solve this problem. It involves motivational part and, you know, like a stick and a candy. This is all I wanted to tell you briefly about some basic things related with how this is being done in our company. And of course, let's leave the questions to the end of the session. And right now, I would like to download. Well, maybe you can ask the question while I'm downloading the presentation by the next speaker. So, do you have questions? You've been speaking about certification. Third-party certification. There is internal certification, and we also have external certification because. But how can you find this situation if you're not able to manufacture unsafe product? Because you have to sell on the certified products to the state authorities. You have received the process, received the paper, and then suddenly, well, product lives in the market, and you cannot do nothing against it. Why we can't do nothing about it? There's a special procedure of updating certificates, safety certificates, and we've been speaking during the previous section on the first floor. It exists, and right now it's being developed in Russia as well. It exists in common criteria in the countries where we apply various requirements, safety-related requirements. These are not months. Sometimes it takes days or weeks, depending on the type of the update. And of course, there's always a certain lag between the discovery of the fault, vulnerability, and fix of this vulnerability. And we have to make this lag as less as possible. We cannot make it zero. Right now in Russia, it's not available because these requirements are not available on the certificational bodies and in a system of certification which is available in Russia. These documents are being prepared, and by the end of the year they will be applied, and we will follow these requirements at the end of the year. Yes. Dear colleagues, I'm being told we are eating time of other speakers, so at the end, after Rustem, you will be able to ask questions outside because we will have another section after us. Denis Baranov, Positive Technologies Company. Hello, dear colleagues. I will speak first of all about automation of safe development life cycle, secure development life cycle, and what were the main ideas during making this presentation, analysis of this approach. So when a human being faces a software code of a certain company, whether it's an internal development or a third-party development, or some people have a desire to control changes in applications that have been deployed already. And what the Microsoft approach tells us to the safe development, secure development. Well, in real practice, at the stage of development, they recommend to use statistical analysis tools at the stage of post-development testing, use the dynamic analysis tools, various phasers. And which problems we do face? First of all, I will begin with the black box scanners. On modern applications, one of the most important moments which stop the full-scale implementation of the automated means into the safe development process is the fact that applications became very complex. So if you will start on a big modern application, any modern scanner, black box scanner that will analyze by a black box method this application, the scanning will never end, and it will never end in an acceptable time, which is a problem to use this product on a full scale from the point of view of security analysis. And what other problem exists for the black box scanning? Another problem is that big different forms of authorization, and it is impossible without any pre-settings to use the black box analysis in vacuum, to use this analyzer. And this analyzer, well, everybody has it right now. Also, everything which is related, while speaking about web applications, in the category of deep web. And I will extend this definition. It includes all hidden values, all the post-authorization activities, and these scanners, they change the condition of the system. If somebody have tried to scan by black box scanner or by phaser admin panels, very quickly these analyzers will find links from the point of view delete user with a name or delete user under the name, and by checking of the parameters they will change the condition of the system in such a way so that further scanning of the system will not be valid. And there's some complexity of false positives, problematic false positives. They happen because there's no possibility to analyze the source code in a full scale, in a full depth, and this application is not applicable for the development process, because development in our days is a cyclical process, and we don't want to, well, in the process, to take a lot of time from the developers and fight against this problem. So we would like to have a fully automated tools. Well, these difficulties will be solved by statistical analyzers and dynamic analyzers of the source code, but when we have analyzed the existing solutions, which problems we faced from the point of view of safe development, secure development process. Well, in our test bed, all the existing analyzers, like it was previously emphasized by Anton, they've let a lot of messages about possible vulnerabilities, results that are received. It's very difficult to process because in most of the cases we see only information about the source code where the vulnerability was found, and we don't see even the vulnerability itself and the message about, well, the object can be null. Well, from the security point of view, it's not really interesting. Of course, it increases the quality of the code when you discover things like that, but the fact that the object can be a null, it's a safety problem or not. It's a question. It's not always like that. In most of the cases, it's not. Why? Because if the object can be null, it's not a fact that you can put your system in such a condition, and it's not a fact that, well, it's not guaranteed that the system in result of this will lose ability to work. Same thing related to the problem of statistical code analysis. This technology faces similar problems like the problems of this theory. So when during statistical analysis, it's also impossible to provide 100% code coverage because a significant part of objectives include the multiplicity of unsolvable problems, and these tools cannot be used for the analysis of business logic. Why? Because most of the analyzers which exist today, they don't understand the logic which is inbuilt in the business processes. This problem can be solved by matching template-based search, but it requires manual work. And all this makes the usage of these analyzers, especially those which are existing right now, a very labor-intensive work. And as a consequence, what do we get in the result? And what do we want to receive from these tools as a result? We would like to receive, if we'll look at the requirements of those who are faced statistical analysis, usually safety departments, we would like to receive a tool with a clear result, with a good speed of work, and very interesting requirements from the point of view, well, the search of NDV and how NDV is different from regular vulnerability. In principle, from the point of view of vulnerabilities, if you think from this point of view, SQL injection, is it NDV or not NDV? In most of the cases, it's not NDV, but in some cases, it is NDV. Non-declared possibility, non-declared vulnerability. And there are requirements which are to the engine, matching engine which is needed to look for functional vulnerability and non-typical vulnerabilities in the source code. And how to solve this problem in our side, in our company, for the tool set which exists in our company, we use all the methods mentioned above, and first of all, we stopped looking for code-related problems related to vulnerabilities, and we generate vectors of attacks. Attack vectors. Well, that's all I wanted to tell you. Thank you very much. If you have any questions, I will answer them afterwards. Do you have 1, 2 questions before I give floor to the next speaker? You can ask one question. How many products you have tested? Because there's a lot of products on the market. Your approach looks like a very narrow niche approach. Well, speaking about what is the main objective of our analysis of these products, we analyze the source code from the point of view, well, I represent the consulting part in side of positive. I was interested in products which are used for searching for vulnerabilities in the source code, first of all. So we've been analyzing interface solutions whose main objective was vulnerability search, and they have a lot of problems compared to what we want to get from these problems. Okay, thank you very much. And final speaker, Rustam Kilitin, General Director of Apple Cloud Security. He will speak about inbuilts and a couple of words about cloud, well, about analysis of this particular topic. As I've promised, well, I will do as it was promised. It is very good when your Yandex or your Cisco and your business is related to the software development, but everything that we hear from people who earn money on development of the software, it doesn't work in the cases when people write software for themselves, and I should do it myself. Okay. Many companies, they are well aware of what is a secure development life cycle. They've been studying it, but they don't implement it. Why? Because in principle, it makes the development process more expensive, and most importantly, it requires specialists, and you cannot hold them by salaries and even by interesting objectives. You know, people write the accounting programs from morning to night for big holding, for on one seat software. And to organize security development life cycle means that you will double the time for development, and you will hold a number big number of people who will be involved in non-interesting objectives. This is also very routine work. The next one, and the problem is such when you have a lot of clients, for example, there's HP data that $1 invested in testing saves $30 on the stage of exploitation, but this is related to products, scalable products. When you have only one client, you yourself, and for you this is not a core business, you oil manufacturer, steel manufacturer, and your programmers provide for your business this security development life cycle very often is a very expensive thing to do. So from time to time, companies have a desire to check what really happens with the code. Programmers very often, if something fails, people face it, because we don't want to fight with one S programmer, because even if you have only one day, because if something will stop working, because we cannot say that the company that develops software for themselves, they are not thinking about the same problems like those companies that develop software and sell it outside, or services with the usage of the software. Of course, all of them are worried about it. So manual analysis or automated analysis is used. Pros and cons are found that in manual analysis, the analysis is deeper, they find more vulnerabilities, but it requires more time, and it becomes outdated faster than the software is being developed. Sometimes it happens that the code study, well, it takes months, and testing done every week. So you have a report about the software that was 3 builds ago. So it makes no sense. Process is not applied, like a mathematician says. So the manual analysis has a big deficiency. And of course, it's deeper than automated analysis. Automated analysis is much faster, much easier. There are services which are located in for certain languages. You put the code, you get the report, and you increase. And sometimes even you do it free of charge. These services work on the freemium model. And for small volumes, they get it for free. For bigger one, you have to pay a little bit. So the composition is selected in such a way. Big builds are studied, big and important. If it's a bank, this system is researched, a big build is studied manually, and then small changes, updates, they are researched automatically. That's how this build. We cannot call it a security development life cycle, because very often it is done not by developers but by security department, because compete or not compete, but it's a contradiction to what Anton was saying, because it has to be in the framework of development. But fact is the following: you know the ideal, but facts are such that very often it worries only security department. That's it. That's why ideally everything that we have for the manual analysis, in order not to have a double work and not create a soft lab, you have to find them and discover them in the framework of automated analysis. So speaking about how can we model threats, threat modeling, when you have a lot of users, especially you're the web service, all your main threats are coming from outside. You have millions of visitors, and some of them can be attackers. But honestly speaking about the software that company develops for itself, very often threats are internal and not external. If this is an internet banking, of course they have problems from both sides, and this is the main problem, that you cannot use crowdsourcing tool like Bug Bounty. You cannot, well, the oil company cannot check their ERP system and check it by this system and pay money for that. So in most of the cases, terms and ways of security development life cycle is not applicable to in-home written software. Most of the developers, they work on the software that they develop for someone, customized software. 1S programmers, well, we have more than 300,000 1C programmers who are in Russia. And you understand what I'm speaking about, the volume of software code that was never audited. And of course, we see the following situation: those people who are involved in the code analysis, they model threats, not threats which clients are afraid, but those that they can search for. And if people can search for SQL injection, they say, well, your main problem are entry errors, but honestly speaking, this is not a real truth. And speaking, they start telling the stories about their own problems. Security people who develop for themselves, they say, well, where there was a situation, programmer did something wrong, then he was fired, then he used it. Some other people have increased their rights in the system and have seen something that he shouldn't see, etc., etc. So threats are available from within, but because scanner doesn't show it, doesn't show all of them, and they say that all problems coming from hackers, but this is not always the truth. So we have to search for both of them. Nobody should reduce problems from some systems, even internal internet banking systems from within, but internal threats, they have to be taken into consideration as well. And as Alexei was asking me, I will tell you about the experience of cloud services. Yes, there are a lot of different services, and private developers, they use them very often. Our company also uses, because it's always interesting to have a second opinion, because there are certain recursings. We provide software for the development of code auditing, and we audit code for other developers who develop code auditing software. And this cross-checking is very good thing. There's not too much scanners. There's no such thing as too much scanners. If there's opinion number 2, number 3, number 4, scanner uses different technologies. That's why when you use the cloud, there's also free means, and very often it is right to start with them. Is there a problem there? Then you can move on. Well, it's understandable that advantages are the facts that it's going to be cheap, sometimes free of charge, but the problem is that 90% of companies think that it is very dangerous to post your code in the cloud, because it will immediately be copied by Google or Amazon, where the service is being hosted, and they will start using it for their own developments. So there's some kind of a power trip. So many people, they want to have such tools inside on their own territory, and naturally speaking, possibly they can have a more fine-tuning, because it's your server, your vulnerability. You cannot add your own vulnerabilities, those which don't exist in the clouds. And on the other side, at least you will have to search for people who can set it up, and you should have a people who can interpret this information, because any report of automated scanner requires interpretation. However good it is, the technical specification to the programmers, it will not replace. If you give a report to programmers, you have to fix it. They will look at it, and they will never be able to understand it, and they will criticize it. You have to show not only vulnerabilities, but also the way of how can it be exploited. Because I was penalized for 1 minute. Well, I had finished. I'm done. This is the final slide. Code analysis should be a process and not a project. That's what it is. Well, thank you very much, colleagues. We have finished on time in 5 minutes. Another section will start, and I would like to suggest, please ask a question to Rustem, and after this we will be ready to go outside and continue answering your questions, so we don't take time from other speakers. Question. First of all, thank you very much for lifting an important topic. I have the following question. You've been speaking about involving security departments, developer department. What should we begin from? It's an important topic. Well, internet store. Internet store it's an internet company, and for them it's a priority. They should do it. Internet retail store, X5 for example, to them it's not a priority business. So the question, what should we begin with? Should we develop this topic from the security department point of view or from the risk management point of view? So what is your opinion? What should be first, risk assessment and demands, or the beginning of the process, quality, good quality development, or the safety for the sake of safety? Thank you. Can I answer it? You have to understand why do you need it, and I think I have mentioned it slightly, because some people need it for compliance, and 99% of safety requirements done because of compliance. That's why we have so many problems in the world with the security, and you need it, your business needs it, if you can explain it to the business, and then processes are following after you get this understanding. In Russia, We have a lot of compliances with central bank, with other organizations. Well, you can come to any bank and you say you have 8 compliances hanging. Well, the problem is not in the compliance, but the problem is in punishment for the absence of this compliance or for non-compliance. So you have to weigh on the scales the legislative requirements and punishment for non-execution of them. For example, a central bank prepares a separate document on secure development and requirements to the security for the life cycle of the banking payment applications. So at the first stage, I assume this document will be of recommendation character. Then, as it usually happens in some time, they will go into the mandatory ones, and then there will be certain practice of testing them in real life, and then we will come to their enactment. For example, Article 34 cap for non-fulfillment of the central bank requirements in the framework of regulation of national payment system and discontinuation of your activities or up to 500,000 rubles of penalty. Then you will have to wait what is more or least beneficial to you, to do the requirements on code analysis or to pay 500,000 rubles of penalty, or your activity will be discontinued. Of course, you will do it on the basis of certain law enforcement practices. In order to say that starting from tomorrow you will start implementation of SDLC in its different aspects. Of course, nobody will say that to you except for the company which sells these services. And then afterwards you have to weight it on scale. Like Anton said, there is no universal recipe and never will be. Well, you started with competitive advantages. For Cisco, as I've told you, this is a totally different aspect. This is requirements of the client, because there are big American companies. For them, this is a mandatory requirement, implementation of these type of processes and demonstration of the fact that they are vendor-based. In big volumes, this is a certification, a requirement from the state bodies of authority and for military objects of a specific in specific countries where we are represented. And of course, naturally speaking, these are questions of cost reduction, because as it was told by Rustem, with mass development and we have mass products, the earlier we will start removing these vulnerabilities, the cheaper it will be on the stage of testing or commissioning. So it's a combination of compliance, requirements of the clients, and economical benefit. Well, thank you all very much. If you still have questions, ask them outside. If you have no questions, thanks once again.